STEM education, instructional strategies, and guidelines reference. Agenda. Why is STEM integration important? Important factors to consider in STEM. STEM educators' responsibility, and all the general resources, instructional strategies, and additional activities for science, technologies, engineering, and math. So why is STEM important? STEM education is important because it promotes students to be problem solvers, innovators, inventors, technology literate, logical thinkers, hands-on learners, and it fosters collaboration and team effort. Important factors to consider in STEM. There are broad goals for implementing K-12 STEM education, which highly promotes the following. It increases advanced training and careers in STEM. It increases STEM-capable workforce and increases scientific literacy for all students. And the overachieving goal of STEM education in the US is to prepare all students for post-secondary studies. With what a lot of research studies shows in the overall theme of being an effective STEM teacher is the enhancement of training and professional development that they attend to that makes a difference in the way the students engage in learning based on the guidance and support that students receive from teachers. Teachers' attentiveness to students' learning needs individually or in groups ensures that there's a positive and productive experience for students. So most of the educator's responsibilities is to seek out and participate in high quality professional development, definitely utilizing and understanding good quality resources from various STEM organizations. And most importantly, school leadership must be exhibiting full support for teachers in efforts to fully deliver an integrated STEM lesson, and definitely collaboration within stakeholders and any availability of STEM education resources that teachers and leaders are able to provide for all the students. So science education is the core foundation in forming scientific literacy, critical thinking, and innovation among students. The understanding of scientific concepts and applying them to real-world situations definitely helps. Some of the instructional strategies that have been examined are collaborative instruction, which promotes teamwork effort in completing projects, peer teaching, and group problem solving. Inquiry-based learning, which is a student-centered investigation where learners actively engage in formulating questions and conducting experiments and drawing conclusions. Also, being culturally responsive when it comes to teaching, teachers being culturally responsive. Recognizing the importance of connecting scientific concepts to students' local experiences, values, and background. So promoting that students learn to have students learn concepts that interest within their own culture and the environment that they're exposed to. Also, technology enhanced science instruction is important as one of the strategies. Integration of technology provides students opportunities for visualization, interactive simulations, augmented reality, which this tool provides students to better understand the scientific concepts through visual and kinesthetic learning opportunities. Lastly, one of the instructional strategies is to differentiate instruction. It addresses various student readiness based on their interests, learning profiles, and adapting a tiered task model. Varying question techniques, content presentation, and assessment methods, which promotes inclusive learning for all students with varied learning needs. The following resources are some of what I found. So Oak Ridge Institute for Science and Education website is a list of lesson plans available for teachers to either utilize as is or to differentiate as needed based on the students' learning needs. So there's a lot of options here. Next one is Science Buddies. It's also a list of STEM activities, projects that could easily be sorted by topics. Topics here, by grade level. And it's also based on the students' interest and what they're learning, the area of topics that they're learning. Lastly, for science, I found PBS Learning Media, which is an interactive video to give students curriculum aligned videos relevant to what students are also currently learning. These are pretty good resources for teachers to present to students, depending on the topics that's being covered in the classroom. And it also can be sorted per grade level. So here are some of the examples of the lessons from the websites that I just showed. For technology, with the increase of technology use everywhere now in the school setting, instructional strategy an instructional strategies to implement is to utilize various educational platforms that provide students with virtual simulations and virtual experiments where they can sort or see videos of real-world simulations, examples of experiments that are happening. Another one is to provide students with immersive environments using technology so they can view 3D models, which allows students to experience augmented reality experience to test out a phenomenon. Another instructional strategy that I found actually pretty cool is the use of gamification. This uses game design concepts and components outside of actual real games, which in education it incorporates elements like challenges, leaderboards, badges, points into instructional activities. And the biggest goal is to inherent incentive or to promote incentives engagement that students more than likely to engage more when it's kind of like a competition. So some of the resources that I found are the nasa.gov, which this website is actually also pretty cool because it gives students a peek of what real world research has been happening in NASA. And this definitely overlaps with some engineering designs and education, but this resource can inspire students in many ways applicable to their interests about space exploration and more. And it's very real life things that's almost like that's happened already. And, NASA people are just kind of sharing it. Another one that I found is Bird Brain Technologies, which this is a website that sells products for STEM designs, incorporating again some of the technology and engineering that overlaps, such as robotics designs and more. So they have like different products and things that can be incorporated in the classroom settings. And lastly, for technology, I found ThinkerCard, which is a technology-based website that allows students an opportunity to design projects like 3D designs, simulations, circuits, simulation labs, circuits. And here is some example of those supporting activities that I found from the website too. Next is for engineering. So engaging students in engineering design helps with applying the following instructional activities. So one of the biggest instructional strategies for engineering is to definitely provide hands-on activities, which gives students opportunity to be part of the design process and use materials that derive from defining engineering problem, solution, and implementation of that solution. Another thing, Another thing is to provide students with authentic, open-ended opportunities, which engineering design stems from the problem-solving approach, where students can be given an opportunity to examine what kind of design they would want to work on, or depending on their interests, like what kind of how they wanted their design process to be. Another thing is to incorporate design justification, which is it's kind of like a requirement or the in the final stage of their engineering design. It's to allow students to demonstrate what they've learned in the design process, to justify their design decisions by means of examining, like the newly acquired knowledge that they gained from the design that they did, and or make changes or recommendations about the design based on the results once they test it. And it also examines students' progress within the progression of their design project. So some of the website, excuse me, that I found is Teach Engineering, which is a compilation of lesson plans that has a real life engineering connection. Like for example, this spaghetti bridge, it has, some type of engineering connections of like how bridges are, civil engineers are responsible of, designing and construction of structures that are bridges, or one that I like just different types of engineering designs that are very much has real life connections. Like physics of roller coaster of like, the engineering connection. I mean, most kids have experience with roller coasters. So like just kind of like giving them that experience and understanding of how engineers, come up with the problem and the solution and designing project of what a roller coaster can be is actually pretty cool. And another one is try engineering, which is it's like a comprehensive STEM educational portal with classroom ready, like free lessons. But it also from the website it shows like they have like this explore try engineering STEM community, which it unites like educators, volunteers, and anyone that's like very enthusiastic with STEM, and it provides like a sense of community in the STEM world. And they do like some type of interactive virtual programs and events. Here's some of those example of the supporting activities within engineering. And lastly, math as part of STEM is an essential component of definitely STEM integration. A lot of concepts within the other discipline definitely derives its core from math instruction. So therefore, it's important to emphasize that instructional strategies for math can definitely be adaptable to fully integrate STEM lessons. And some of these instructional strategies are definitely like problem-based learning, direct instruction, direct and explicit instruction, different opportunities for students to learn at different stations, different learning tasks, and definitely like project work of what can lead them to other STEM activities or designs that within the scope of math concepts. So some of the website, the general resources that I found is from Mathematical Association of America, which is it's kind of like from what they describe on their website, it's one of the largest community of mathematicians students and enthusiasts, which where they it's kind of like a support for professional development, where they further understand, the world through math and, because math drives society and shape lives. And like I said, it's kind of like the core foundation of STEM education. So it's a pretty good resource for teachers to utilize and really learn from in terms of like learning more about math concepts and things like that. Another one that I found is Gebra Math, which is it's like a free tools of interactive math experience for students to explore math concepts. So it's more of like a kind of like a technology driven experience for them too, because they're able to explore it through like using the Chromebook in class or things like that. And then lastly, so Museum of Math is located in New York, which a bunch of exhibits dedicated to many different math concepts. I think this is a good resource for, to provide students that truly hands-on learning experience and like kind of like a field trip for them to do or to explore. It has a lot of like exhibits that they literally could explore in the museum and really like learn all of those math concepts within exploring it in a fun way. So it's pretty cool. And here are some of the activities that I also found. I use even like the Oak Ridge Institute because they also have some math concepts there. And even like going back to Science Buddies, they have like different math concepts there too. So a lot of this website, which this assignment really gave me so much depth of knowledge with different resources available for STEM activities, lessons, and just interactive platforms. And I found that a lot of the resources overlaps within the STEM world, which is a good sign that, a lot of integration is happening in STEM education, and it definitely builds, you know, from one discipline to another. Alrighty. Thank you so much.